Hello, Julian Mustangs. This is Miss Otter, and this is our last math YouTube video that we're going to be making. This is going to be for Math Spiral Review, May 21st and 22nd, the last problems you will ever do as a 4th grader. So let's go ahead and get started. So the first problem is simply an addition problem. We always start with the ones place, so 3 plus 1 is 4. 8 plus 2 is 10, put down the 0, regroup the 1. 7 plus 1 is 8. 9 plus 7 is 16. Put down the 6, regroup the 1. And 1 plus 1 is 2. So your total answer here is 26,804. All right, for the next one, find the product for 34 and 28 using the area model. This is how we usually find it anyways. So we're trying to multiply 34 and 28. So what I'm going to do is I'm going to pull apart the 34 into 30 and 4. And then I'm going to pull apart the 28 into 20 and 8. So now we're just going to take and multiply those boxes together. So 30 times 20 is 600. 20 times 4 is 80. 30 times 8 is 240. And 8 times 4, of course, is 32. The last step for finding product using area model is going to be addition. So we're going to add up 600 plus 240 plus 80 plus 32. Okay. Start in the ones place. You have a 2. 8, 9, 10, 11, 12, 13, 14, 15. Put down the 5. Regroup the 1. 6 plus 1 is 7. And 8, 9 for a total of 952. All right. Find the sum of these two fractions and shade the fractions in to show your answer. Again, fractions sometimes sideways look a little strange, so if I were to go ahead and cross these out, I would have 7/8 plus 3/8, and this just makes it easier for me to tell what that denominator is. The denominator looks like 8, meaning that when I solve this problem, my denominator is also going to be 8, and then 7 plus 3, which is 10. So when I'm showing, it says shade the fraction to show your answer. So I'm going to go ahead and shade in 7/8. 1, 2, 3, 4, 5, 6, 7. And then I'm going to go ahead and shade in 3/8. 1, 2, 3. You could have done it several different ways. You could have put one of the blue ones here and then not put another blue one here. However you did it, though, as long as you had 10/8 shaded, you are correct. Okay. The line plot shows how many miles each person ran. 2 runners ran 2 miles. How many quarter miles did they run? So when they say that 2 runners ran 2 miles, we're looking at these 2 X's on the 2 line mark. And then when I zoom in, I see that between 0 and 1, there are about 3 hash marks. So I know that this is going to be 1/4, 2/4, 3/4, 4/4 for 1 whole. So each of those is a quarter mile. There's a couple things I could do. I could just figure out how many quarter miles are in 1 and then double that, or I could just go ahead and hop over like this. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 quarter miles. How many quarter miles did they run? They ran 8 quarter miles. Sorry about the sloppy writing. Okay. All right. Can you explain why 1/10 is more than 1/100th? This one is kind of fun. So if we look at 1/10, this means that if you have a candy bar, you are only sharing it with 10 friends, because I think a lot of people or a lot of students want to automatically say 1/100th is bigger. So what that means is if you're looking at 1/10, it means you've split this up into 10 pieces and you get 1 piece of this candy bar. So here's my 10 pieces, and clearly easy to draw. I'm going to go ahead, I'm going to shade in. That would be the equivalent to 1/10. Now, 1/100th, it sounds bigger because it sounds like it's the bigger number, but what this means is you're sharing the same size candy bar with not only you, but also 100 of your friends. So imagine having about the same size candy bar. Oops. Well, here, let's do this again. Oh, okay. Let's try this again. Same size candy bar, but now you have to split it up into 100 pieces. So what I'm looking at is I would split it up into 10, And then each one of those 1/10 pieces would then be split into another 10. So you're looking at, I'm not going to draw it for you, but you're looking at one of those pieces, if I really zoom in, you're looking at one of those pieces being split also into another 10 pieces. So let's see if I can possibly make that work, because this is getting crazy. So here we go. Almost got it. Into 10 pieces. Holy Toledo, these are small. Okay, so pretend like I did that with all of these sections, because that would make 100 different pieces. So 1/100th of something is going to be about that much, meaning that when you're comparing how big your piece is going to be, 1/10 is clearly the bigger size than 1/100th. So if you're trying to explain why 1/10 is more than 1/100th, you could say something like, because you have to share with fewer people, fewer pieces, there are less pieces that get cut in half that you need to have, something to that extent. But just kind of showing this picture is one of those ways you could have done it. All right, look at the regular pentagon. How many lines of symmetry does this feature have? All right, so they're meaning like if I cut it up and I look at the shape, are they going to make the exact same pieces on the side? So I'm going to go ahead and start with some obvious ones. If I were to cut this pentagon right here, that would make a line of symmetry. If I were to cut this pentagon then right here, this is also a line of symmetry. That means that they're making those shapes. However, if I were to turn this around, so I'm going to go ahead, I'm going to flip this around. If I pretended like this was the top part of my pentagon, then here is another line of symmetry. Oops, let me change. Here is another line of symmetry. And then also, let's see where to go. Here is another line of symmetry. Oops, I'm trying to change it, I can't. Then also here is another line of symmetry going straight through, oops, going straight through here. And so I have 1, 2, 3, 4 lines of symmetry, and I know that I can fit one more. Oops, sorry, I'm going to have to move it around again. I can fit one more right here. Oops. Whoop. So a pentagon, being a 5-sided shape, actually also has 5 lines of symmetry. 1, 2, 3, 4, 5. Yeah. So when you're looking at that, I'm going to try and rewrite this again. Or not rewrite, but change it up. So when you're looking at this, how many lines of symmetry does this figure have? Well, it has 5 altogether. I could color coordinate each one. You can do it for yourself, but 5 lines of symmetry for this one. Okay, let's go ahead and go to our next. This is going to be the May 22nd review. Looking at this word problem, I saw that it looks similar to others, but it is slightly different. Let's zoom in. William bought 6 new video games and 3 used video games for $117. Man, he had a lot of money. Each new video game cost $17. The used video games were all the same price. What is the cost for one used game? So our ultimate question is, what is the cost for one used game? Okay. We have a couple of things here to note, though. We have the total amount he spent. We also know that he bought 6 new video games and they each cost $17. And we also know that he bought a total of 3, but we don't know how much was spent on those. So I'm going to start with my total. So my total is $117. I know he spent $117. Then what I'm going to do is I'm going to figure out how much he paid for each of the or how much he paid in total for the 6 new video games, because I need to know the used price, not the new price. So I'm going to take 17 and multiply by 6 so I can figure that out. So 6 times 7 is 42. Put down the 2, regroup the 4. 6 times 1 is 6 plus 4 is 10. So here's what I know. I know that he spent a total of $117. And he spent 102 of that $117 on the new ones. So I'm going to take and subtract. Oops, I almost put 107. I'm going to take and subtract these two numbers. And the reason why I'm doing this is because this is what I know. Or this is the total, and this is what I know. I'm going to find out what's left over to be able to divide it into 3 video games. So 7 minus 2 is 5, 1 minus 0 is 1, and 1 minus 1 is 0. So he spent a total of $15 on all 3 video games, meaning that this $15 went towards all 3 games. So what we have to decide is how much was each of those games, or you have to take and do 15 divided by 3, or 3 times what gives us 15, which is a total of $5. So he spent $5 on each of these used video games. Of course, you need to write a sentence. All right, use a model to demonstrate why 2/5 is the same or equivalent to 4/10. There's a couple of different ways we can do this. I'll start with the picture. So if I have a fraction, I'm going to go ahead and make it into fifths. Hopefully that's pretty accurate. And it says that he had 2/5, so I'm going to go ahead and shade in 2 of those pieces. And then what it says, I'm going to go ahead, is that we got to show that it's the same as 4/10. So here's my 2/5 fraction. I'm going to go ahead, I'm going to cut this bad boy in half this way. And bam, all of a sudden I have 1, 2, 3, 4 shaded out of 2, 4, 6, 8, 10. So there it is. That's how I could show that 2/5 is equivalent to 4/10. I can also write an equation for this, and I can say 2/5 times a whole number of some kind is going to give me my 4/10. When I'm looking at this, that means that 2 times something is going to give me 4, and 5 times hopefully the same number is going to give me 10. So looking at this, I know that 2 times 2 gives me 4, and I know that 5 times 2 gives me 10. And that is also a method to show that 2/5 is equivalent to 4/10. All right. Select all the fractions that are equivalent to 8/10. Remember, this 0.8 is, we say 8/10 because this 8 is in the tens place, but it can also be written like this. So when I look at these, I clearly see right away that D is going to be for sure the correct answer. Some things that I can rule out are these ones with the denominator of 8. Okay, those are numbers bigger than 1. And this number has no whole numbers, so this is clearly not going to work, and this one's clearly not going to work. I also see that E, when I look at E, it's 80 divided by 10, which is going to give me 8 wholes. I also had a student tell me that, look, if I took off the zeros, that equals to 8/10, but it actually equals 8 divided by 1, which is also an 8 whole number. So E is also not going to work. And last but not least, I have A. A looks tricky because it looks like it's 80 hundredths, which it is, but if I pull off the 0 here and the 0 here, what I'm left with is 8/10. And so A is also equivalent. When you're looking at this at decimal form, 8/10 look like this, and 80 hundredths looks like this. So all I did was add this extra 0 here to get my 80 hundredths. And in decimals, if you want to take that 0 away or put that 0 there, it doesn't really add on to the place value of the number on this one. Okay. The line plot shows how many miles each person ran. What is the difference in miles between the longest and the shortest run? So the shortest run is going to be here at 2/4. And I know that because if you zoom into 0 and 1, you clearly have 1/4, 2/4, 3/4, and then 4/4 for 1 whole. Okay. So the least amount that they ran was half a mile or 2/4. And the most amount that these people ran would be up here. And that is going to be 3 2/4. So the most someone ran was 3 2/4. So what I'm going to do if I'm trying to find the difference, and we all know that that means, that's right, subtraction. So what I'm going to do is I'm going to go ahead and I'm going to subtract. Let me see if I get some room. I'm going to subtract 3 2/4 minus my smallest distance, which is 2/4. Pretty easy. I see that I have this number 3 right here. Okay, so I'm going to keep my 3. Now that all that's left to do is take and subtract 2/4 minus 2/4. Well, same number minus same number is going to give you 0. So I actually am left with just 3 whole miles. So we have the distance. You could have also counted if you wanted, but this is much easier. 3 2/4 minus 2/4 is going to be 3 miles exactly. So the difference in miles between the longest distance and the shortest distance ran was 3 miles. All right. Oh man, you guys, this is so easy. We've been talking about this place value chart and the tenths and how to look at that in fractions and decimals. So I'm going to go ahead and go through this pretty quickly. 1/10 is going to be the same thing as 0 whole numbers and a 1 in the tenths place. 2/10 is going to be the same thing as 0 whole numbers and a 2 in the tenths place. 3/10 is going to be 0 wholes, 3 in the tenths place. 7/10 is going to be 0 whole numbers and a 7 in the tenths place. 5/10 is going to be 0 whole numbers and a 5 in the tenths place. That easy. Now I'm going to look at doing the opposite. So when I see a decimal of 0.2, that means my numerator over 10 is going to be 2 for 2/10. 3/10 in decimal form is going to be 3/10 in fraction form. 4/10 in decimal is going to be 4/10 in fraction form. 8/10 is, of course, 8 with the numerator. And 6/10 is going to have you with a 6 in the numerator. Pretty easy stuff, especially if you grabbed onto that concept of tenths. Okay, here it is, the famous last problem of 4th grade. It says draw a vertical line of symmetry in the shape below. Vertical means that it has to go straight up and down. It's not a sideways and it's not a horizontal. So when I look at this problem, here's my line of symmetry. I'm going to draw a vertical line straight up and down right here through the triangle. And that is it. You have officially finished the last problem of 4th grade at Julian School. I will hopefully see you around campus next year. Have a great summer, you guys.